Hello, everybody. Welcome. We have quite a few participants today. That makes me happy. Before I start, I'd like to thank Dr. Aldag for organizing this whole series. And I think it's a great opportunity for graduate students to catch up on things in a very convenient way. Also, lots of thanks to Patricia Bellarno-Vera. She organized everything so well. So thanks a lot for that. This is an intro to R, and I really like to do that. I consider myself as an R evangelist. I stole that from Microsoft. They say Microsoft evangelist. The idea is you try to convince people to use a certain software. And I think R together with Python is by far the most advanced software you can use. And I want to show you that it is also a convenient software. I can't give you an introduction to R in 1 hour. And I don't need to do that because there's so many resources available on the internet. And you can find these resources. I prepared a little flyer for this talk, and it's available online. I will update it later on with the video, with the link to the video for this talk. So it's tinyurl.com, and then rtalk, and then my last name, Lang, L-A-N-G-E. So you get that, you get this page, redirects to another page. What are we doing? I will show you today how to install R and RStudio. I will not show it to you, but I will give you some hints how to do it. I will give you some tips and tricks for RStudio that will make your life way more easy. That includes how to import data from Excel. And most people know it. If you work with data, it's, if you're lucky, 80% data wrangling, cleaning of the data, organizing the data, and so on and so on. There is a great tool, and it's not called tool in R, it's called the library. It's a tidyverse. It became the quasi-standard for working with R. I will show you a little bit how convenient data cleaning can be. We will look at two commonly used tools, regression and t-tests. I think social scientists often like to use t-tests. Other scientists also use regression. Social scientists, of course, use also regression. So these are the very standard tools. I will show you very briefly a machine learning tool. And I will show you very briefly, I can't show you how you do it, but I can show you the results, how you can report results in R that are very pleasing to your audience. They come in HTML file, PDF file, or even in Word file. So let's just start. I provided two links here where you can download R and where you can download RStudio. What is super important to know is you have to install R first. RStudio is just a user interface that sits on top of R, and if you haven't installed R first, everything is getting a little bit more complicated. Whenever you ask in the installation process if you want to install the binaries or the source code, always choose the binaries. That will keep you out of trouble with versioning. Here are the links how to install the tidyverse, how to install import Excel data. That's a short video. Where can you learn more? There is a free DataCamp course. DataCamp is a great site. Unfortunately, not always free, but this one is free. I bought a subscription and I thought it was well worth it. But there are a lot of their courses are also free. You will get the recording of this workshop by the weekend, I would say, at the latest. You will see the R scripts that I used in this workshop, and you can download the data here. Here's some literature, an introduction to RStudio, very, very short, very well written, and you don't even have to read it all the way to the end. And another workshop that gets you step by step through sample files to an introduction to R. Only hint I want to give you here, normally in a workshop, you can just skip the introduction and go to where this one, you have to read it really word by word from the beginning and stick literally to what they say because you want to use the same file names as they do. Here's a free book from Hadley Wickham. He is the R guy. He is basically the person who founded the tidyverse. It's a great book. It's a little bit more advanced, but eventually you probably will go there. And here's an introduction to statistics with R. That's something you might or might not have to do. So these are the sources I want to provide you here. What is very important if you work with R, if you work with data, every project deserves its own folder. So whereas my folder here it is. That's my folder. And what you usually have in a folder when you start, you simply have your data there. So your folder at the beginning is probably empty except this data file here. And that's pretty much it already. So we can start. Let's close this one and let's start RStudio. Here it is. That is how RStudio looks like. And for me, it was very, very confusing to see what these different windows are. There's a total of 4 windows. One is here. These are your files. Here are your variables. Here is your console. That is where actually R runs. This is where the commands are getting executed. And the fourth one you don't see, that would be your R script where you save your code. Before we start, a hint that is very, very helpful. There is something called the R workspace, which is very confusing and quite honestly, very useless. So what you want to do is you go to global options and go to general. And here it is, restore R data into workspace at startup. No, this should be not checked, uncheck it. Save workspace to R data on exit. Never, you don't need it. Always save history. I would recommend not to do that. Saves you time and you really don't need it. So make sure these are all unchecked. It makes your life way easier. Okay, so let's see how R works. So I type A equals 2. That is where actually things happen. And you see here, this is the window where your variables are stored, A equals 2. Now I say B equals 2 or B equals 3, saved here. And I can use these variables, obviously, C equals A plus B. And this equal needs to be interpreted as assigned to. So you assign A plus B to the variable C. And here it is. So here you always can see your variables. That is often very interesting when you have to know what's the value of a certain variable. Well, if I leave now and I come back, my work is gone because I didn't tell R to save my workspace. So this is probably not the best methodology. What I should do, and that's the best workflow, I work with the R script. So I open a new file, an R script. Here it is. And I do the same thing, A equals 2. And now what happens here, I just want to restart R. So R has forgotten everything. What happens here if and I don't click in the script window, I don't click return, I click control return. What happens if I click control return? Nothing happens in the script window. It looks like it. What it does, it copies the code down to the console and executes it there. Let me do it for you. A equals 2, shift, enter. B equals 3, shift, enter. C equals A plus B. And here we are. So what's the difference? Well, if I save my file now and I reopen it the next time, then I'm in this state here. R doesn't know anything, but at least I have the text, and it's really the text only that is saved in my file. And what I can do very quick, and I recommend doing it like this way, I would go control enter, control enter, control enter. I am where I was. And if you don't have super time-consuming processes, and most of them are not super time processing, this is a better way to make sure you have a consistent workflow and you know actually what you're doing. If you're impatient, and I would not recommend doing that, I take the time and do it one by one, and I observe the console window if something happens that is unexpected. But if you're really impatient, what you always can do is I restart R forgets everything. And I click here on source, and what it does is it saves the file, be careful, and executes all lines in it. Boom, done. So that would be the faster way. Well, this file now would be saved somewhere here in a weird directory. Well, what I want is that I always work with my project directory. And this is another hint here, what I would recommend as a workflow. When you save your first file, or even when you start, before you start, go to File, and you have to do that only once. And you say New Project. You have your directory already because that's a directory where your data are in. So you say Existing Directory. You find your directory, which is usually a pain because there are a lot of subdirectories, but you have to do it only once. Here is my directory. I say Open, and I say Create Project. So the advantage now is when I start over, I start from scratch here again. Everything's gone. And I would be in some weird directory. Here I'm still in my directory. And I say File, Recent Projects. It loads my project, and it really doesn't do a lot, but it sets my working directory here as a standard directory. And everything that I save ends up in the directory where it's supposed to be. It sets a little marker. Here's a project file. See it as a marker that marks the working directory. So now I can load my file that I had saved before. And instead of saving the file with the A+B, I save the file that I prepared before. No variable is saved here. The variables are empty. I start always from scratch, and that's a really good workflow. I strongly recommend to do that. You can execute commands directly in the console window. I do that if I want to test something and I don't want to mess up my script, but normally the code that you want to keep should be here. So I start library tidyverse. And when you do that, you might get an error message and it says it doesn't exist because it's not installed. You try to load something that is not installed. You go to Tools, Install Packages, and you type tidyverse. Click Install. I don't do that. And then it installs, and you have to do that only once. But when you use it, you always have to say library tidyverse. I do that here. And again, if you're asked if you want to install the binary or the source code, always choose the binary. I run the tidyverse here. It loads it. It loads quite a few packages that are very useful. I load something else here. We need it. You don't necessarily need it. You need the tidyverse almost always. Tidy models makes your life way easier when you clean your data. This library allows you to get a glimpse at your data. We will use that later. And now I want to load my data. They are in an Excel file. And let's keep a little space, so assume there's nothing there here. Here's the trick. First of all, let's look at the Excel file in Excel. You can do that from here. Instead of import data set, I say view file, then it opens Excel. And what I like to do is, when I have a data set, I load it in Excel, wherever it is coming from. I have comments there, and you see so many variables. These are the original data here. And then I copy and paste this sheet here in Excel, move or copy, create a copy, and I create a copy, and I call it something like data CL or data clean, and I do some cleaning already in Excel. So I did some cleaning here. This is a data set about wage from the 70s. Later on, we want to see if these wages or these employees discriminated against women. The nice thing with that data set, because it's from the 70s, we know already they discriminated. We know the result already. That makes analysis way easier. And the data set is actually a nice data set. It is complete, but I sabotaged it here. So we have some data missing here for education here, some for the sex. So this data set is a little bit screwed up on purpose. Normally it would be clean. And I have a third one here that says where the data set is coming, where I have some comments and so on. That is how I organize my data in a Excel spreadsheet. It's more like a hint, you don't have to do it. I close Excel, and here comes the trick. RStudio has a very convenient way of importing data. Import data set from Excel, and I search for my data. It searches automatically in my working directory. Here's my data set. You want to be careful because it searched in the default sheet. I don't want that. I want to have the clean sheet. I get a preview of my data here, and you can see here the missing records already. And now you would probably just click import. And here comes the trick. You don't do that. Instead, you copy the code in your clipboard and you write cancel. Well, if you do that and you then copy it in your R script, you can use this code over and over again. And you don't have to go through import dataset. So I did this here already. This shows you your data. So let's do this. Well, I want to use my one here because I changed the name here. I called it wage.data.org. Everything else is like it was. So I execute, I load my library here. Wage.data.org. What it does, it loads the Excel file. The same thing that if I had clicked import, I can view my data. Either I can use the view command here, or I can simply click here on this thing here. And what I see here is what I expect, my variables and the missing variables here. Okay, this is the skim command that I have because I imported this library here. So if I say skim, and R is always the same thing. You have a function, and then you have a bunch of arguments in the parentheses, and this is usually the data set you're working with and with some extra ones. So I do this, and I get a glimpse at my data. And it's saved here in the variable skim.org. So I want to see that variable here. And I don't want this in my code, so I do it in the console. Here I get a glimpse at my data. That's really good to start with, to see if everything is what you expect it to be. So let's start here with the character variables. Non-white, that's basically the racial variable. Sex, married, the SMSA if it's a SMSA, if it's a statistical metropolitan area, we don't even need this later on, the region and something else. But these ones we need here. And we can see here, there's one record that doesn't have a race, or that doesn't indicate if it's non-white or not. The coding is yes or no. There are 3 records that are missing. They don't indicate if it's male or female. This one shows the shortest one is character is 4, the longest character is 6. Yeah, correct. For male and for female. This for non-white, for no, 2 characters. Yes, 3 characters. So we see our data set is not perfect. We have holes in our data set. And we have wage, education, experience, tenure, and a few other ones. And we see here again, education has 2 missing records and tenure has 2 missing records. Okay, if I know that, I like to clean my data set. What I also saw, I saw the average value, and I saw the average value for education was 12.6. And that kind of surprised me, but I guess being in a university area, you always think there is more education than there is. But I said, is that really right? 12.6 as an average, 12.6 years as education. So what I do here is I plot my data. And R has already histogram plot in R just with one command, but I strongly recommend to use ggplot. ggplot is, you have to get a little bit into it, but if you use it, you get really, really nice looking diagrams. So what's the logic? First, you say where your data are coming from, wagedata.org, that's where they're coming from. And here inside the AES, which stands for aesthetics, and don't ask me why, it's basically your data definition. You say, what is your X and what is your Y? It's a histogram, so we only have X, which is the education in years, and the histogram is automatically counted. This is the first place here. That is, no matter what data you have to do this. And then you add here plus what type of diagram you want to have. It starts always with the name geom, and then in this case, head histogram. So I shoot this off here, and you could do it like this one here. Then it goes directly. You don't have to save it in a variable. Then what you see here, in your lower window where you had your files before, there's also a tab which says plots. We can see a histogram. It's a little ugly, but I wanted to show you the easiest way of a histogram. We can make it a little bit more pretty. You just say the outline color is black and the fill color should be red. Here's the histogram. You can save it as a PNG file if you want to use it as in Word or just look at it. And we can clearly see 200 of our records, of our about 500 records, were actually people who just went to high school. There were a few with a higher education, but there were also quite a few of high school dropouts. So this seems to be reasonable. I don't have to be concerned about my 12.6. Now I want to clean my data. And there are many ways to do that. And if you look for data cleaning, you often find very complicated ways of doing that. If you clean your data and you use the recipe command that comes with the tidy model, we imported it here, everything gets so much easier. You just have to get into the logic. They had a sense of humor, so they treated data wrangling like cooking. And they thought it's funny. If you share that or not, I don't know, but they probably thought it's funny. So we start with the recipe. Think about a recipe. A recipe, usually if you see it in a cookbook, it starts with a list of ingredients. Well, same here. Recipe is a command, and then you list the ingredients. And I don't want all the variables. I want only some of them. I want wage, education, experience, tenure, the racial variable non-white, which is yes if it's non-white, no if it's white, and sex, which is male and female. These variables I want, and I have to give a little bit more information. I have to say, which is the variable I want to analyze? That's the first one. And then variables are usually separated with a plus. This doesn't mean there's any addition involved. It's more like an and. And just the first one that separates the one that is analyzed from the one that are used for the analysis. You don't use a plus, you use a tilde. This is just something to remember. Of course, we have to tell R where we get our ingredients from. See that as this might be the cupboard where you get your ingredients from, wagedata.org. This is a weird command. It's called the piping operator. It chains commands together. So think about this like a funnel, the sign. Whatever comes out here as a result goes in the funnel and gets pushed into the next command. So our recipe puts the ingredients together and pushes them to the next command. These are the steps. Wash the vegetables, broil them, put the steaks in a pan, and so on and so on. These are the steps. So our first step is we want dummy variables. Because think about it. Non-white is either yes or no. There's no good calculation done with yes or no. You need numbers. So we transform this non-white into zeros and one. The nice thing is R does that automatically for us with this dummy variable here. And here I tell R which variables I want to convert into dummy variables. I could list here non-white, sex, but I can also say all nominal variables, all character variables. That saves me a lot of time. What R does, it renames these variables. The non-white variable is renamed to non-white underline yes, which means the yes, the non-white yes, is coded as a 1. So from this variable name, I can immediately see if I see a 1, it's a non-white person. It's a person of color. And if it's a 0, it's a white person. Same with sex here. The variable name gets changed automatically by R to sex male in this case. I know if it's a 1, it's a male. If it's a 0, it's a female. Okay. So I do that here. Then whatever the result is, I pipe it, I push it to the next command. And remember, education was missing something. There were holes in education. So what I say here, filling holes in a data set is called imputation. So what I do here is that impute the education variable, put something in there, and just choose the mean of all the other variables. Okay. Then the result where education is now repaired goes to the next step, and non-white yes. Think about it. These are 0 and 1s, and if I have a hole there, I don't want to have the mean, and I put a 0.35 in there. What is that? Right? It's a dummy variable that tells me yes or no, so the mean doesn't make sense. In this case, I just say simply the median. Fill the holes with what is most often occurring in my data set. In this case, I believe that was white. Done. This is something very advanced. it's a machine learning procedure. What it does, and I do it for tenure, and I probably would have done it for all of them, but I want to show you a few more interesting ones. It finds the most similar data set to the one where we have the holes in. And then it fills the holes with the entries of the most similar data set. That makes a lot of sense. That is called KNN impute. So this way I repair my tenure. The only thing that has holes now is my sex variable that is now renamed to sex male. Well, there's a little bit of a problem with that one because this is my most important variable. I want to do research about gender discrimination. Do I really want to fill it with something like a mean? And it's only 2 records. I don't. I have enough records. In that case, I just decide if there's a hole in the variable sex, just throw it out. At the end, I say prepare, that's it. I save the recipe in a variable. I call that recipe CL. I like to add my initials to some variables, so I know these are not R code. These are variables I named myself. You can have another convention. Done. So the data are already inside the recipe. So if I want to get them out, and again, we're in a cooking world here, we just have to say juice. This kind of squeezes out my data from the recipe and assign it to a variable that I call wage data. Done. I look at my skim, and I don't save it in a variable here. Just push it to the console. Everything that is not saved in a variable is pushed directly to the console. And what you can see here is we have less data. We used to have 526. We lost 3 because these were the ones that were dropped because they had holes in the sex variable. And we can see all the other variables are now complete, 100% complete. So that's good. And we can double check. No holes anymore. At least you can hope. You would have to go through all the 500 variables. I suggest not to do that here to save a little time. Okay, then let's proceed here. I have my data and I want to see if there's discrimination. Well, the first idea is probably getting a visual. So I do a box plot here, and again I use ggplot, and what you see, it's exactly the same than the other diagram. That's the charm of it. You have the command ggplot, you have the aesthetics here, and inside the aesthetics you define your x, which is the sex, because we want to have 2 boxes, one for male and one for female. And the y-axis is actually the wage. I have to say where the data are coming from. Now they come from wage data, not from wage data.org, from the clean data. And that's what I always have to do. Here's a plus. In the next line, I say which type of plot I want, and you can combine plots in various ways. Execute the line. And here's a nice box plot. I can blow it up. And we have already some indication. 1, remember, is coded as male. It seems like that the mean of the main salaries is higher than the one of females. So we get a basic idea. These ones are, this one is a 25 percentile. This is a 75 percentile. It's a standard box plot. If you're not so familiar with box plot, or if you simply don't like it, like me, we can just skip that. So now we run a t-test. A t-test compares 2 means and has a hypothesis that these means are equal. Well, because we want to show that there is gender discrimination, we probably want to reject that hypothesis. There's one problem. You can run the t-test only if the variances of your female wages, in this case, and your male wages, if they are equal. But there's a test for that. It's called var.test. And you see everything repeats. Wage is a variable we analyze. Sex male is a variable that discriminates between male and female. The data are coming from wage data. Shift enter. Here's the test result. And the important part is this one, the p-value. The probability that these two means are the same is basically 0. So we can reject the hypothesis that there are, the probability that the variances are the same can be rejected. So they're not the same. We cannot run a regular t-test. Nice thing with R is that the t-test command, I would usually do it like this. That's a regular t-test, but again, I can only do that if the variances are the same. That one has a parameter that says var.equal. And if you set it to false, it uses an adjusted t-test. It uses actually the Welch test. You don't have to care for that, you get the result. What brings me to one thing, what if you get stuck? Well, you can use the help function from R, but R has such a big user community. It is always more effective to type it into Google and look for it. Somebody had your problem before. I would strongly recommend just use Google, go to some forum, and you will get the answer. So I run the t-test here, and I get a lot of information here. The woman's salary was 4.5. The men's salary was 7. And that looks like they're different, but that's not enough. But I can reject the hypothesis that are the same, because the probability that they are the same is very close to 0. So it looks like we have gender discrimination. Well, from a statistical point, that's not enough, because you could say, well, that is maybe not gender discrimination. That is because in that time, especially in the 70s, women had less job experience because they were expected to raise the kids. They might have lower education because they didn't have the access to universities and so on and so on. So we want to correct for this. So we better run a regression. Running a regression is very easy because things repeat. You see, everything repeats here. You just a new command, LM for linear model. That's a regression. The variable you want to analyze, your outcome variable, is wage. Then comes the tilde. Here's something very convenient. The dot says use all the variable in the data frame. That's what I want. Which data frame? Here. So I run the regression, and the results are stored in model LM. And I look at the summary, and here's the summary. All my variables are significant, almost all of them. They all have a probability of being 0 that is very small. That's why they get the star here. With one exception, that is non-white. Yes, that is not the probability of being that the coefficient here is 0 is not close to 0. So this one is not sufficient, is not significant. We don't want it. All the variables have the right sign. A year of education increases the salary, experience increases. And being a man, sex male variable is 1, also increases the salary. It looks like there's discrimination, but we want to do it right. Let's take out the non-significant one. And again, that's super easy. Instead of I have to do a lot of typing, I use the same command than before, wage, tilde, use all variables. That's a dot here. And then I say minus. Minus is not the arithmetic minus. It just means don't use the non-white variable. Control Enter. And here is my model. I have a nice model. All variables are significant. If the variable sex male switches from 0 to 1, the salary increases by $1.80. That means, yes, there is sex discrimination. And yes, we already corrected for other variables. Nobody can blame us now and say you did not correct for other variables. So I hate to say proven in statistics, but we have evidence that there was sex discrimination. What I want to show you, and I don't go into the details, I want to try something interesting. What if we could use our data and predict the sex? So we look at all the data we have and we try to predict if it's a male or if it's a female. I think if I would give you the data table and I erase male or female, you would have a hard time to find out if it's a male or if it's a female. So would I. So I use a machine learning procedure here, and I don't go in the detail. This is a little bit of the show part here. And I have to change my sex variable, sex male. It has to be changed into a dummy that is internally saved in a different way. It's a technicality. I do that here. I want to make my results reproducible, so I initialize my random number generator, and I do something what is in traditional statistical analysis done very rarely, and it should be done. I split my data set by random. 85% of my data set becomes what is called the training data. These are the data that I use to improve, to optimize my model. Remember, regression, we just used all of them. And 15% of randomly selected data, I take them at the side. I don't look at them. And these data are the data the model has never seen. These are the model data that I use to evaluate, to assess the quality. In regression, we use the training data. We used all the data. This is actually not right. Here I do it right. In machine learning, this is standard. In standard regression, it's unfortunately not so much standard. So I have a training data set, and I run my model here, and I don't want to go into the details, but what you can see here, my random forest model is very easy to set up. And the last one here is something we know already. It repeats. It's just called fit and not LM and not t-test. So I run my model, and it's quite a complicated model, and R is pretty fast. It was just a split second. And here are the results. And I don't go into the details how I generate them. Just show you the results. If the true record was a woman, a 0, 158 were actually predicted as women, and only 56 were falsely predicted as a man. From the men, only 50 were predicted as women falsely, but 182 were predicted correctly. Well, that was the training data set. That is what outside of machine learning often is used, but that's not right. We should make it a little bit more difficult. These are the data here the model has never seen. And it's not as good, it's a smaller data set, but you can see here, 27 predicted correctly, only 10 predicted wrong. 30 predicted correctly for the men, only 10 predicted wrong. And that gives us an accuracy rate, and there are many other measures, of 74%. And I think that is pretty good. Again, this is more to show that you can do sophisticated things, and that comes all with tidy models if you want to. You probably have to read it. It looks a little bit easier here because you probably have to do a little bit reading to get these commands right, but you can copy and paste a lot, for example, from the script when you use it, because I put it online. The last topic that is missing is data reporting. I cannot go into the how, that would take us too long, but I can show you the results and how powerful it is, and I can give you an idea. So we have our script file already that has all the code in it that calculates everything. And you probably saw it, that all the things I calculated, almost all the things I calculated, I saved it in a variable. And now you will see why. I open another file here that I created. That's called R Markdown language. It's like HTML a little bit. And it has a header file here that I just copied and pasted. I want a table of content. I'm the author. This one puts the actual date in it. I want a certain theme that I haven't created, that somebody else created. I just use it. So that's a header file. And then I import some libraries here. And now I have titles here. This is a major title because it has £1. This is a minor title. So this becomes 1. This becomes 1.1. And I write some text here that describes my methodology. Then I say execute my code. Now I have something new, data cleaning. Well, my code is already executed. So now I can show what was saved in the variable skim.org. I don't know if you remember, but I saved the glance of the data, of the original data with the missing data in this variable. It gets printed. And so I go on, and you see I have the t-test here, the box plot, and so on and so on. So this one basically mixes comments with my R code. And the nice thing, it's totally independent of it. So when I deal with my R code, I don't need this report. I know what it is. So I can deal with my relatively slim R code. But when I want to give it to others, I want a report. So I execute this here. I have a little bit to do, takes a moment. And what it produces is a nice looking report. These are just preliminary results and they don't look nice at all. And it is in HTML. Here it is. It has a table of content. It's interactive. Look, here's my box plot. Here's my test for equal variance. Oops, I have a spelling error here. Here's my regression. Here's my random forest model. First the code, and then the results. So it's a perfect report. And everything in here, and if you look at the code, it looks scary. Look how nice the image is fit in here. Just, you don't have to say how big it is, like in Word or so, where you have to say a little bit bigger and boom, it jumps to the next slide. No, it's in there. And it's all one HTML file. You can put it on the internet, link to it, everybody can see it. You can give it to a collaborator, they just open it in your browser. You don't like HTML? Well, no problem. So what I can do here, you see my command, it used HTML as standard. I can generate a PDF file. That looks pretty nice. It doesn't look as nice as HTML, but it is still interactive. And some people like Word so much that they want everything into Word. That's fine too. I can create a Word file. My report is in a Word file. If your collaborator says, I don't want to deal with PDF, I don't want to deal with HTML, I like Word, put it in a Word, and your collaborator can start editing that file. Again, it takes a moment. As you can imagine, there's some calculation power behind it. Here's the Word file. It's not interactive. like PDF and HTML, but it's nicely formatted with different colors even. See, this was, remember, we had the variables, we had at the beginning 526 variables. Sex was missing 3 entries. This is basically our first glance at the data. Here was after the imputation. Here's our histogram, nicely fit in there. So it takes a little bit of reading how to do these things. It's a little bit more advanced, but you can see if you go there, you can work so effectively. Because what happens to me is I work with machine learning a lot. I work with different collaborators, and I have a new collaborator and I say, this is a no-brainer. I did that before. I look at my code and I don't understand my own code. And that can take forever until I get there that I understand it. Well, I just generate a report every time and I know exactly what I did because it has the comments. And I also can send that to my collaborator, or you can use it to enter it into your paper or into your thesis. Thank you very much for coming.